Okay, we're here today on September 7th, 2023 with Professor Marco Castaldi at the City College Chemical Engineering Department. Good morning, Marco. It's nice to see you.
Hey, good morning, Stu.
Okay, so what we'd like to do today is to get a session where we hear something about your life at CCNY, your group, and so on. So to get started, why don't we talk about how you got here? What was your path to getting here?
How I got to CCNY. It's actually a very personal story for me, and I tell you briefly. When I graduated from UCLA in chemical engineering and combustion, thought, should I go for academic or industry? And I thought, okay, let me try academic, and of course, I'm a New Yorker, so I wanted to get back to New York, and City College was always very familiar to me. It's a very well-known institution here, not only within New York, but kind of the Northeast and a little bit further. And sent my resume in, and what was really nice was I got a phone call from a chair that said, Bob Pfeffer, who said, you know, you got a great resume, great background, great work that you've done, go get some industry experience and call us. Okay, thank you very much. So that helped me make a decision, go to industry and get some experience. So I went to work for a small company, Precision Combustion, great experience. I was there for about 6 or 7 years. Did a lot of work with combustion, catalysis, catalytic combustion, worked with components for bigger companies like GE, Siemens, Westinghouse. And then after being there for about 6 or 7 years, I said, let me see what teaching's about. I started adjunct teaching at Manhattan College to get an idea. And I thought, yeah, I think I do want to still go into academia. So leaving PCI, I decided, let me send a chance for a job here at CCNY. And there again, a great response in terms of a chair, Irv Renard, contacted me and said, you got a great resume, you got a great background, you got industrial, something we're really looking for. Can you wait for 2 years until we can open up a position? And I said, no, I'm sorry. I said, I need to make the move. So I took a position at Columbia University in 2004 in the environmental engineering department. And I was there for, again, about 7 years or so. And time to maybe move. I really wanted to get back to chemical engineering. And I said, okay, one more try. And I sent the letter to CCNY's chemical engineering saying I'm looking for another position. And chair called me back, Alex Kuzitz, who's the dean now. And he said, don't make any decisions. We're going to get a position. Let's talk. And sure enough, in 2012, I made the move to come here, kind of back to my roots of chemical engineering, but finally at City College.
So the industrial background really helped you. The mixture of the two seems to have been a really interesting thing for you.
Yeah, I would say the industrial background, personally for me, if I didn't have that industrial experience and along the way as I developed my research at Columbia and then of course even expanded it further here, I kept in touch with these industrial contacts. And you know, right now about half or maybe a little bit more, 60% of our funding comes from industry. So, you know, companies, small startup companies that you maybe never heard of, like in Enerchem, all the way to companies like BASF, Waste Management, the American Chemistry Council. So that industrial experience for me really helped because it helped me understand the difference between fundamental research and what I would call applied engineering research. Research to solve a problem for industry, but then also research in terms of fundamental to kind of understand it and interrogate some fundamental aspects.
So being on this academic side now, have you had people that have worked in industry for a number of years come and apply to this department and to get a degree, a higher degree, and have the mixture done that way? Has that been possible?
Yes, actually my group the personal experiences that I had was, of course, students that come out of undergraduate to go straight to grad school. But I've had a couple of students where they were working in industry, they wanted to continue their education, did their master's, of course that's easy to do, but then signed on for a PhD, and they stayed at the company doing their coursework with the PhD, and when it came time to do research, they either peeled away from the company a little bit, or we developed a project with the company that they were able to finish their PhD, and two of my students did that. And then of course others, right, they just quit 100% and they come, full-time, and that's a decision what they want to do.
Okay, so can you tell us more about what goes on in your lab as far as work, research?
Yeah, so the research that goes on in my lab, the name of the lab is the Combustion and Catalysis Lab, CCL, and that's because I did my PhD in fundamental hardcore combustion, and then while I was in industry, a little bit in graduate school, but then also while I was in academia, moved really into catalysis, and it's the applied catalysis. We don't synthesize catalysts, we've done that, but primarily what we'll do is understand the reaction mechanisms on the catalysts. We will compare them and screen them and so on, do a lot of testing, and we will interrogate them down to a level of either just how much conversion you get, yield, durability, all the way to do isotope labeling of reactants to understand, which are the real active reactants and which are things like spectators, and where do they sit on these catalyst surfaces. We've done work with Brookhaven National Labs and the beamline to understand exactly what changes on the catalyst metal might be happening. On the combustion side, we still do fundamental combustion. For example, I have a student who is looking at detonations, because there's a large amount of work in understanding detonations in extremely controlled conditions. But we have one of the largest blast chambers where we can put different geometries in there and understand if there is a combustible mix and it happens to detonate, does that attenuate the detonation, or does it strengthen the detonation? And specifically, we're doing work for that with Con Edison. They commissioned us because if you ever go onto YouTube and you look up manhole explosions in New York City,
Right.
you'll see a video, and what they're trying to understand is not only how does that all occur, but how does the strength of these detonations launch a 300-pound manhole cover 150 feet in the air. And luckily to date, no one's gotten hurt on these things, but we're doing those kind of investigations. So the other side of the combustion that we also do is a lot of what I would consider waste to energy. So they're not looking at gas phase or liquid phase fundamental combustion, but more looking at how to take waste materials, literally garbage, or biomass and others, and how to use the inherent energy in there to make either other products. So we take waste plastics and we turn them into precursors for plastics again. That's a nice combination with the catalysis, because after you say thermally pyrolyze plastics and make an oil, we're putting them through a fluid catalytic cracking process to then make olefins to go back to plastics. So there's a lot of synergies in this combustion and catalysis lab, even though they might sound like they're completely different. There's a lot of overlap.
And it also sounds like it's playing into the transition that is going on in all of our lives.
Oh, sure. I mean, one thing that I think a lot of people don't know is garbage that we throw away is 2/3 renewable. So just combusting that in a standard way and making steam and making electricity, you're making renewable energy, 2/3 of renewable energy. But there again, the stuff that we throw away is remarkable because there's a lot of materials that we get back. Copper, aluminum, silver, gold. So we get materials recovery. Most of our work, of course, we get tasks and everything from industry, and we write to agencies like the Department of Energy, National Science Foundation, has a very large environmental component to it. I would say 90% of the work that has gone on in the combustion and catalysis lab since I started has been, of course, to understand at the fundamental levels, but how could those processes be improved, or what kind of environmental impacts do they have? So that's a large facet of the research we do. For example, even in the detonation space, there's a lot of interest in taking, and you may have heard this, things like SAF, Sustainable Aviation Fuels. There's a lot of companies trying to convert waste materials into a fuel, and honestly, they look at it and say, it's got the pour point of a fuel, looks like a fuel, smells like a fuel, viscosity of a fuel. We actually do the testing. We have engines that we do testing on, and what we found is that while some oils actually help the engine to perform a little bit better in terms of a thermodynamic efficiency, they yield a little bit more emissions. And so now the question is, okay, are these fuels that we're making, what is the overall environmental benefit to that? And at least we get the hard data behind it. We see a lot of times that there's a lot less NOx because these fuels that they generate don't have the nitrogen components of a typical fossil oil, but sometimes they don't burn as well, and so they generate a little bit more unburned hydrocarbons. Which one is better and which one is worse, right? So this is the kind of, I think, areas.
It's a very environmentally, in some ways, focused effort that you have.
A lot of it is, yeah.
And so what is it like for a grad student, comes to your lab, is here, decides that they want to work with you? What is it like for them then?
Well, you'll have to talk to the grad students.
I
They'll tell you what it's like for them. What I like to tell the grad students, and I think this rings true, is one thing that's very important is they will have a project that's their main focus, but they will do other projects. And again, just coming from industry, yes, you're maybe a subject matter expert, yes, you're the lead on a task or a project or something, but you are supporting other projects. You are using your skills to support other efforts. So that adaptability has to be developed. And so in my group, every student has more than one project in the sense that they got their main PhD work, but we'll get, let's say, a project coming in from an industry for 3 months. They'll say, we just want to screen this or check that. Okay, this is, if it's a catalysis thing, we'd say, okay, well, the students who are doing catalysis, this is not exactly what you're doing, but it's catalytic, looking at a little bit of a different facet, and it's only for a 3-month stint. Usually we publish a paper from that, right? So it's not like it's just work that gets done and we hand off, go to presentations. So the students that come to my group, 85% experimental. We do have to do some analytical work, whether that's just MATLAB program to process data and so on, or write mechanisms and so on. But we also have done in the past things like Aspen, CFD, and so on. So there's a component of, I'll call it, non-experimental analytical modeling that gets done, even if it's just reaction engineering modeling. But they'll be working in the lab on an experiment. And we, I think, have, again, coming from industry, I know we can buy pieces of equipment that are so automated that you put the sample in, you press a couple of buttons, go away and come back a few hours later, and all the data's there. And then, of course, there's the other side of it where you have to kind of build it all yourself and do it. There's a nice happy medium. And I have really geared the work that we do and the projects that we do where things that the students should put together, like a reactor, where whether it's horizontal or vertical or how you introduce the reactants, very, very important. You need to understand that. So to have that built is, to me, very valuable. But then we use the right analytical equipment. We'll buy all of the GCs, the online analyzers, everything will be mass flow controllers that will feed it, so we're not dealing with rotometers. So I like to think that the work that gets done in our lab is a combination of unique, hands-on building yourself reactors and systems, but with the right amount of equipment to make, when you're done, have a system that's quite robust. And some students will even like automate and program. We have LabVIEW. Some students like to use LabVIEW, so they'll automate everything, and some students don't like it, and they just download the spreadsheets and then process it themselves. And that, there's merit to both sides of that. Does that answer, you think?
Yeah, thank you. That's a good answer. So, for example, generally, how big a group do you have? How many grad students, postdocs, undergrads? I know it changes with time, but in general.
Yeah, so again, I like to take from my industrial, and I still work with industry now. I still work for GE Aerospace, so I have some teams under me. I purposely try to keep the team, I think it's considered small, anywhere from 4 to 6 PhD students, one postdoc. I have a center, the Earth Engineering Center, that really we can talk about later, but that's really where companies come in and they want 1 month worth of work, 2 months worth of work, and who knows what's going to come out of it. It's almost like a survey, sometimes a literature survey for them. And they all have engineers. Like there'll be a student who have graduated with their bachelor's and they're looking for a job, they'll work there. So they all have maybe 1 or 2 engineers. So in total, the group size, and of course we have undergraduates. We have undergraduates that come in. But the group size has never really gotten more than 10. And I would say in terms of the PhDs, it's between 4 and 6, because that's where most of the focus needs to be, and that's something that I think we all could handle. We work very well as a team, though. It's not just me. The postdocs, the more senior students work very, very closely. We have a very good culture in our group.
Very good. So in general, how do your students, is part of the reason that they come here, does New York have an appeal, is what I'm trying to ask. This is a very vibrant city, it's a very busy city. What are the students, and we'll talk to a few of them later, but how do you feel? Like, is it an advantage to them, or?
Well, okay, first of all, New York City is the center of the universe, and so how could it not be? I would say there's a couple of facets to that. One is, you're in a city that, there's no dorms here. So, however, many students live within a 2 or 3 block walking radius because there's just so much around. We're in historic Harlem and right next to Alexander Hamilton's house, so that's great. Or, just a subway ride, you're down in Lower Manhattan, near Times Square, even some of them even going to Brooklyn. That's a little bit too far, I think, but they go there, Queens. So there's a lot of options in terms of living in the city in what you want to experience. To me, the real big attraction is you've got multiple universities around here, and we have collaborations with all of them. And so what I like to tell the students is that coming here, you're literally limited by your imagination. That if there's something you want to do, we could get a collaboration that's close. First of all, City University, CUNY, has one of the most advanced, research centers. It's called the ASRC, the Advanced Science Research Center. And that is where a lot of the schools, Stevens, NYU, Columbia, send their students to do research. And this is on our campus. So, if you're intimidated by a big city, there's opportunities to stay close. There is a dorm here, but usually gets filled up quickly. But if you want to have some level of a city experience, it really is what you make of it. And I would say the the students that come here, I think, have an element of wanting to be in New York City, but I don't think that makes or breaks their decision. I think most of the students, at least that come to me, for sure, because I've gotten individual requests, but students that come to CCNY, it's the work that's going on at CCNY, it's what CCNY has to offer, and then it's in the city, and they can, take advantage of aspects of the city for there.
So could you give us a little rundown of some of your former students and where they're at and what they're doing now once they've finished up in your lab?
Oh yeah. One thing I will say that me personally I'm very proud of is every student that has graduated has had more than one job offer. And again, what I specifically pay attention to is when a student graduates, I don't want them to just take the first job offer they've got. I have forced some of my students to go visit other companies, even though they had one that they wanted to go. I said, no, you need to see what's out there and make an informed decision. Because to me, the end result of all of this is not that you get your PhD, not that you really do a lot of work in interesting areas, not that you learn a tremendous amount, but that you're going to get a job for the rest, for most of your life, or the career that you're going to make. You really enjoy what you're doing. The groups that we've had, the students that we've had in the past from the group, I would say 20% of them are in academia. I've got a student who's a faculty at Korea, student who's a faculty in Cooper Union. The other, 80% are in industry, in companies. One student who was very high up in ExxonMobil did very well. He actually just left and started his own company. And I think, there's a little bit of that entrepreneurial spirit in our group. Not only are we working with small companies, doing some research, but, you get ideas. But I've got students that are at BASF, at GE Aerospace, working at waste management. So Clariant. And so I would say that the students that when they finish usually take a position that is in chemical engineering, but like a little bit, it's not typical process engineering that one might think of, or petroleum engineering. I've got a student that's working at like the American Chemistry Council, right? And there you need some hardcore understanding of what goes on and how to make plastics and so on, but there's a large, policy aspect to it. But these are some of the companies, like I said, BASF and ExxonMobil.
So it's a really varied assortment. They have opportunities in many different places.
Right. And the key, like I said, is that I allow, so first, because they've done some research for companies, already there's an exposure to that. And that's another thing I want to...
Do they interact at all with the company?
That was something else I was going to say. Again, coming from the kind of background and experience that I have, I understand I cannot always be, and I don't want to be, the face, the interaction, the communication to the company or to the agency. The students who are doing the work, they're the ones that give the presentation, that give the debrief, that when the company comes, they work with them. And so to me, it's all about making sure that they get that one-on-one or get that exposure, get that interface with the customer, whether that customer is the NSF, the DOE, or BASF, or ExxonMobil, or whoever it is, that they get that interface, because this is what's going to have to happen. They're going to have to work with these types of people. So they really get, I think, the right exposure. And then when it comes time for them to start looking for a position, they have an idea of what they like and what they don't like. They've had some interactions with some companies. I know one, I'm not going to mention the name of the student of the company, but one student that worked for a very well-known large company did some excellent work, and he was interfacing with them, and they had some, real demands, and we were able to keep up. But in the end, he said, that company does some great work, but I'm not sure if I really want to work for that company. And that's very valuable, because at least you know what you don't want to do, and that's good.
So, to sort of come to a conclusion here, so what would you recommend for someone who's taking a look at this and thinking, yeah, maybe I'm interested in considering CCNY, maybe I would like to work with Professor Castaldi. Is there some way they could, what makes sense for them to either get in touch with you or to learn more about what's going on? What would you recommend for them?
Sure. So the best thing that a student must do is visit. Have a conversation. So send me an email. This is the easiest way, of course. We could have a conversation and phone call, but you have to come and see the lab. You have to come and see the place, because you can really only get so much, from kind of afar. And I know a number of students that have come and they were on the fence, and not just me, but really within our department, and they came to visit, and then you have to talk with the students that are here, right? These are the ones that are living, breathing it, going through it, and they're going to give you, their experience, which, is different, right, than my experience. I mean, I'm here, and these students have just come or have been here for a while. So definitely feel free to reach out to former students. We have a great webpage, CCL, and there's all the former students there. A lot of them find each other through LinkedIn. But then you could contact me, of course, directly. We could have a conversation. And then if there's real interest, I would recommend that they come visit. Could I add one other thing?
Yeah, certainly. Before we finish, please add whatever you'd like.
One of the things that's important in this day and age, and I've recognized this, very fortunate I recognized this many years ago, is the work that engineers do, especially chemical engineers, the type of area we're in, combustion catalysis. It's very international. It's global. And one of the things that I do in my group is I make sure not only that these students have these other projects and so on, but that they get to not just go to conferences, but get an international experience, or I'll say get an experience outside of my lab. We have collaborators around the US, and we have collaborators around the world. And students will go to the collaborator for 3 months or 6 months, and they're doing research there. It's not an overlap. They might have some equipment or some activities or things that we don't have, so it's complementary, and they can do some tests and measurements, but then they learn other skills, of course, but then they get to live in places like Italy, France, Japan, Brazil. And except for the poor students who went through the pandemic, every single one of my students has had an experience outside this lab, either to Chicago or to Japan or to Italy or France. And I think that's a huge benefit.
I couldn't agree more. Having done it myself when I was a postdoc, it was a life-changing experience.
Yeah, and you get to understand how to interact with these different groups and cultures and how they think, right, a little bit differently. Yeah.
Okay, well, Marco, thank you so much for spending the time with us today. And I hope the prospective students that may watch this get a good flavor for, how interesting and fantastic it would be to come and work in your group.
Great. Thanks, Stu.